So y square is equal to capital X plus 1. Now the line x is equal to 1 intersects x is equal to y square in the points 1 1 and 1 minus 1, right? So the required volume is V is equal to minus 1 to 1, right? Because of this x is equal to 1 intersect this parabola in the point 1 1 and 1 minus 1. The limit of this integration is minus 1 to 1, and this is the formula pi x square dy, right? Now because of instead of x we can write down y square minus 1, right? Because of, you can see this capital X is capital Y square minus 1. So this is equal to integration minus 1 to 1, pi will be outside, instead of x this is y square minus 1 dy. Now this function is an even function, right? So that's why this can be written as integration from minus 1 to 1, that can be written as 2 0 to 1. So this is equal to 2 0 to 1 2 pi is also there. So 2 pi integration from 0 to 1 y square minus 1 whole square dy, right? And now we have to find the value of this integration. That is quite simple. 2 pi, first of all simplify this term y square minus 1 whole square, so that is can be written as y raised to 4 minus 2 y square plus 1. Now integration of this term, that is 2 pi y raised to 5 upon 5 minus 2 y raised to 3 upon 3 plus y 0 to 1. Now put 1, so this is equal to 2 pi. When we put 0, the whole term becomes 0, so right, so we don't need to put 0, just put 1, so that is 1 by 5 minus 2 by 3 plus 1, that is equal to 16. This is equal to, finally we get 16 by 15 into pi, right? When we take LCM, 15 5 into 3, the LCM of this term, that is 15, so you will get 3 minus 10 plus 15, right? So 15 plus 3, that is 18 minus 10, so 8 into 2 16, so 16 pi divided by 15. Okay, so here is the answer. The volume of this term is 16 pi divided by 15. Next question. Question 4c. Use the shell method to find the volume of the solid generated by revolving bounded by y is equal to x and x is equal to 0. y is equal to x, x is equal to 0 and y is equal to 1 about the x axis. So you can see the line, here we have line y is equal to 0, x is equal to 0 and y is equal to 1. So the graph of this term is, this is y is equal to 0, right? This is x axis, this is y axis. The line this equal to y is equal to 0, y is equal to 0. This is x is equal to 0, this line is x is equal to 0 and this is y is equal to 1. So this line is y is equal to 1. Also we have y is equal to x, right? Instead of y is equal to 0, here we need y is equal to x. So this line is y is equal to x, this is y is equal to x and y is equal to 1. So this is line y is equal to 1. Okay, this is y is equal to x. Now for rotation about the x axis, here y is equal to x. For rotation about the x axis, we take a typical shell of radius, we take a typical shell of radius y and height x. So the required volume V is equal to integration 0 to 1 2 pi into cell radius into cell height. Dy. So this equal to, this is x, right? Cell radius is y, this is cell height is x, but we know that x is equal to y. So in both the case we can write down y into y, so that is y square. So 2 pi will be outside. This is integration 0 to 1 y square dy. This equal to y cube by 3, 0 to 1. Now this equal to 1 by 3. So 2 pi by 3, right? So the final answer is 2 pi by 3. Next question, question 5a. Show that xy tends to 0 0, limit xy upon x square plus y square does not exist. We want to prove that the limit of this term, does not exist. So let's see how we check it. Xy upon x square plus y square, right? We want to check that the limit of this term when xy tends to 0 0 does not exist. So here we are taking two path, right? Here we are taking two path. The path 1, first of all, is x tends to 0 and then y tends to 0. So by taking path 1 as x tends to 0 and then y tends to 0, right? x tends to 0 and then y tends to 0, we get xy tends to 0 0 limit xy upon x square plus y square, that is equal to x tends to 0 limit, first of all you are taking x tends to 0, so that's why here write down x tends to 0 limit, then y tends to 0 xy upon x square plus y square. So applying y tends to 0 on this term, first of all we get 0, right? Okay, so this is equal to 0 and then x tends to 0, so also we get 0. Now similarly if we take path 2, for y tends to 0 and then x tends to 0, we get same here, y tends to 0, right, in bracket x tends to 0 xy upon x square plus y square, so again we get 0. So in these two cases we get the same limit, but if we take y is equal to mx, let's take y is equal to mx. By taking y is equal to mx, by taking y is equal to mx, we get f of xy, by taking y is equal to mx, f of xy is what? x y. So x y, where y is mx, so we get x square into m upon x square plus y square. So again we get x square plus m square x square, right? Now x square will be common, so you will get and cancel out from numerator and denominator, so you will get m upon 1 plus m square. Okay, now when we take x is equal to 0, because we are taking y is equal to mx, so in this term there is no y, right? So next when we take x is equal to 0, here there is no x, so the limit will be same, when x is equal to 0 on f of xy, where y is equal to mx, the limit is same, limit is m upon 1 plus m square, right? And this limit is depending upon m, this limit is depending upon m. Okay, so that's why the limit does not exist. Why this thing happen here? Because in real number, you can see, just try to understand, in real number, in real line, if you want to find out this a, the limit of x tends to a, right? To go from a to near from a, there is only two ways, either we are going from right side or we are going from left side. So sometime we check the limit of right side and left side, and if these two are equal, the left limit and right limit, if these two are equal, then limit exists, and whatever the answer, that is the limit of this answer, right, f of x. But when we are talking about the two variable xy, when we are talking about two variable xy tends to ab, okay, so here we have whole plane. So suppose this is a ab, there are infinite ways, to near, to go near from ab, right? But if you want to prove that, if you want to find out two way which is near go from ab, which is near from ab, and in this two way the limit does not exist or sometime limit are not equal, then we can say that limit does not exist. Same situation happen here, where you can see here we are taking y is equal to mx, right? Here we are taking y is equal to mx, so m can be anything, m is any real number. So f of xy is equal to, when we f of xy where y is equal to mx is x square m upon x square plus m square x square. X square will be common, m upon 1 plus m square. So that's why the limit, of this function is m upon 1 plus x m square, and this limit is depending upon m. When we change m, the limit of this function will be changed, right? The limit of this function will be changed. Suppose m is equal to 1, if we take m is equal to 1, we get 1 by 2. If we take m is equal to 2, we get 2 upon 1 plus 4, so 2 by 5. So in each and every case, when we change m, the limit will be changed. Okay, so here we complete the solution of this question paper up to question number 5a. Thank you.